Our fifth presenter for the day is Amanda Dale Balso, a master's student under the supervision of Professor Subhasis Ghoshal in Department of Civil Engineering, and she'll be presenting today on a tiny solution to a big problem, the use of nanoscale fertilizers for improved nutrient delivery in plants.
I've always loved plants. See, there's the proof. Little Amanda up there was a very diligent young gardener because she knew if she gave her plants the right amount of water, sunshine, and fertilizer, well, then they'd grow, right? Well, unfortunately for little Amanda, she was very wrong about that, and the situation's not that simple. See, she naively assumed that the fertilizer she was giving her plants was actually being used. In reality, most of the nutrients we apply to soil don't even make it to the roots. Most get carried off into water bodies or just stuck in the soil itself. And ultimately, about 90% of the fertilizer we apply to agricultural soil is wasted. So to avoid this, we need to find a way to give fertilizer to plants without putting it on the ground. One alternative that people are trying is to put it on the leaves, but that doesn't really work with normal fertilizers because they simply weren't made to do that. My research aims to address these issues by developing nanoparticle fertilizers that are highly efficient at delivering nutrients to plants when applied to leaves. You see, plants have these tiny pores on their leaves called stomata that open and close to allow gas exchange with the atmosphere. But nanoparticles are even tinier. So by applying them to the leaves, they can get taken in directly through these stomata and then get transported to different parts of the plants to be used up. My nanofertilizers are special, and I'm not just saying that because they're mine. See, I start with a core particle, like let's say nanohydroxyapatite, because it contains nutrients like phosphorus and calcium, and then I add a mesoporous silica shell around it. I've previously demonstrated that coating particles in silica can enhance their mobility in plants, meaning you get a better distribution of the fertilizer throughout the entire organism. In addition, the porous nature of the shell means that the nutrients inside can dissolve more slowly, resulting in a more prolonged and consistent release of fertilizer over time. And as a nice little cherry on top, plants just love silica, and it's been shown that they grow better when they take it in. I'm going to be testing my particles by applying them to tomato and wheat grown in my lab, because these are crops of huge economic importance. And from there, I'm going to measure the elemental distribution of nutrients across the plant tissues, as well as tracking biomarkers related to overall plant health, with the ultimate goal of verifying if my particles are actually effective and efficient fertilizers. Because the lack of fertilization efficiency is killing our agricultural industry right now. We apply upwards of 4.6 million metric tons of fertilizer per year in Canada, and 90% of that, potentially, is completely wasted. And that figure also represents a huge amount of carbon emissions and dollars lost. Nanofertilization is a very powerful tool that has the potential to allow us to meet our agricultural needs while avoiding significant resource waste and environmental pollution. And I'm hoping with the contributions from my research, nanofertilization will one day be simple enough for even the youngest of gardeners to use. Thanks.